Okay, so for this video, I'm going to explain about length of line segment, and we're going to talk about, we're going to discuss about a couple of questions here. Okay, so and here the formula is only one, which is d equals to square root of x2 minus x1 square plus y2 minus y1 square. So basically, it's just like finding the distance between the horizontal distance and the vertical distance, and then you do like a Pythagoras formula, actually, like that. Yeah. So let's just go and jump to the example. Here we go. So find the length of the line segment joining each of the following pair points. So let's go to A in here. So we're going to find the length from point A to point B. So if you see in Cartesian diagram, for example, if point 2.3, not 2.3, 2,3 is, for example, in this point here, this is A, 2,3, and 9,7 is approximately over, okay, over here, right? That's B. Okay, now if we drag a line from A to B, right, it will make a line segment, right? So we want to know what's the length of this line here. So basically, guys, if you understand Pythagoras formula, it's going to be easy, because if you see that, we can actually draw a right angle triangle from here, right? So I can just like go here, and then I can go here, right? See, this is a right angle triangle. So you can actually use the c square equals to a square plus b square, right? So basically, this formula comes from here, okay? But yeah, let's just use the formula for this one. Okay, so we know that point A is 2,3, and we know that point B is 9,7. So let's name them first. Okay, so x1 and y1, and x2 and y2. So if you are using this as x1, so this one must be as y1. So you don't name it this is x1 and this is y2. Don't do that. Okay, so if this is x1 and y1, then this is x2 and y2. So it doesn't really matter, actually. For example, if you choose this as x2 and y2, this is x1 and y1, it doesn't matter. The result will be the same. Yeah. So for this case, I'm going to use x1 and y1 over here, and x2, y2 over there. Okay, now let's use the formula. So which means that the distance will be equal to the square root of, okay, so x2 minus x1, so it's 9 minus 2 squared, and then add it with 7 minus 3. Okay, so 9 minus 2 comes from here and here, right? x2 minus x1, and 7 minus 3 comes from 7 here and 3 over here. Okay, I forgot to put the square, so put the square over here. Okay, same thing with the formula. Yeah. Okay, now we only need to calculate. That'll be 9 minus 2, this one is 7, right? There'll be 7 squared, and this is 7 minus 3 is 4, and there'll be just 4 squared, and then there'll be square root of 7 squared is 49, and 4 squared is 16, and you only need to add those two numbers. There'll be square root of 65, and then there we go, you have the length of line segment AB. Okay, now let's jump to next question. I would like you to try B and C. Okay, so I would like to go to example D this time. So basically, they are the same thing. I'm just gonna name the x1 and y1 and x2 and y2. Okay, so assume that this is x1, that will be, this one will be y1, and this is x2, then this one will be y2. So finding the distance from point G to point H is just using the formula. So there'll be D equals to square root of minus 7 minus 2, right? Minus 7 minus 2 squared, and then add that with negative 4, and then subtract that with negative 10. So in here, be careful, guys. If you have a negative a number that being subtracted by the negative number, so that'll be positive. So this two, if you combine it, it'll be positive. So if you're not very sure with the calculation, just use a calculator. Okay, so square root of negative 7 minus 2 is minus 9 squared. Don't forget to use the bracket, guys. That's very, very important. And then negative 4 plus 10, that'll be 6 squared. Okay, that'll be equals to This is 81 and this is 36, and if I add them I will get 117. Square root of 117. Okay, there you go. Okay, let's do another example. If the distance between point A, which the coordinates is p comma 0, and B is 0 comma p, is 10, find the possible values of p. So there's a couple of keywords, guys. If we say find the possible values, with as meaning that you might will have more than one answer. Okay, so let's just do it. Okay, so let's name that. The first thing first, you need to name it with x1 and y1, x2 and y2. So this is x1, this is y1, this is x2 and y2. Remember, it doesn't matter if I choose this is x1 and y1, this is x2 and y2. It doesn't matter. Okay, as long as you're being consistent with your process. Okay, so now we know that the formula for the distance of two shape, the distance, right, which is the square root of x2 minus x1 plus y2 minus y1 squared. Okay, so I'm going to write down here the d equals the square root of, I'm just going to write down the name of the coordinates. It'll be p and then 0, so it'll be p minus 0 square root of p minus 0 and then squared, and then plus it's 0 minus p squared, also squared. Okay, now since we know that the distance is 10, so you can actually put it 10 over here, right, exactly below the one that we know. And then the square root of p minus 0 is just p, so p being squared is just p squared. And then the same thing with this one, 0 minus p is minus p being squared is going to be positive p squared, right? And which means that we can combine this because both of them are like terms. They'll be 2p squared. Okay, now remember that if we want to solve this algebraic equation, remember that we need to make the variable alone in one side of the equal sign. So which means that we need to get rid of the this 2 and this 2 and this root over here. Okay, so let's do it from the root first. So we can actually cancel the root by squaring both sides. So I'm gonna square both sides. So this will be 100. So this will be just 2p squared because square root being squared is just to the power of 1, right? So it's just that. Okay, now let's go to the next one. So we can move the 2 to the left side. There'll be 100 divided by 2 equals to p squared. So p squared equals 250, but we're not done yet because we need to get rid of also the square. So remember that in algebra, if you have variable being squared equals to some number or values, so when you get rid of that, there'll be plus minus square root of 50. Why is it plus and minus? For example, like this: if I have x squared equals to 9, then you will say x is square root of 9 and x equals to 3. But actually, this is not the only answer because we know that 3 times 3 equals to 9, right? But negative 3 times negative 3 is also equals to 9. This is going to be positive. So that's why you add plus and minus over here. Yeah, plus and minus. So here, this is the possible values of p. Okay, now let's go to example 3. Given that the coordinates of point P and Q are minus 2,6 and 9,3 respectively, so this is point P and this is point Q. Find the coordinates of the point R that lies on the y-axis such that PR is equals to QR. So we have already know the point P and Q on the Cartesian plane. For example, is P is over here, for example, and which means that the Q is approximately, for example, like this. So it doesn't matter which one. Yeah, you can actually like draw that in the Cartesian plane, but for this time it's just like a random point. Okay, so let's say I have this point here, and then I have another point which is R that lies on the y-axis. So if I have a y-axis, for example, like in here, I'm sorry, I should make a straight line like this, for example, right? So that point R will be on this right line. Okay, it can be here, it can be here, it can be here, it can be anywhere. Now, but in here it said that point R lies on the y-axis, but PR equals to QR. So it can be like in two places. Like for example, if it's over here, for example. So if you drag a line, if this is R, if you drag a line from P to R, and then if you drag a line from PR to Q, and they will have the same exact distance. Okay, so maybe my drawing is not good. Okay, so we don't know the R yet, but let's find it out. So we know that the point P is the coordinates is -2, 6, and then we know that Q is 9, 3. Now we don't know the R, but actually the R will be 0, y. Why is it 0? Because it is on the y-axis. Okay, so the axis is always going to be equals to 0. So y is here because we're looking for that point. Okay, so notice that if I say that if it say that PR is equals to QR, so if I drag a line from P to R, yeah, this is not to scale it, guys, so maybe the drawing is not too good. And then if I drag another line, for example, from here to here, these two lines will have the same exact distance, or at the same length, right? So which means that if I can write down as, okay, length of PR, okay, will be equal to length of RQ, right? PR equals to RQ. Okay, now we can search it one by one. We can find the length of PR by combining this one and this one as x1 and y1 and x2 and y2. Okay, so this one will be the square root of, I'm gonna start with the y first. It's actually the same thing, or maybe I'm gonna start with the x. So it'll be 0 minus -2 squared, and then add it with y minus 6 squared. Okay, that is for the length of PR. Now the length of RQ is actually the same thing. I'm gonna start from y minus 0 minus 9, for example, squared, right? 0 minus 9, and then we have another one which is y minus 3, and don't forget to write down the square, yeah, plus y minus 3 square. Okay, now we only need to solve it. Okay, so on both sides of the equal sign we have square root, right? So we can just like open that square root. Okay, and then next one is this one. 0 minus -2 is 2, so 2 squared is 4, and y minus 6 square, you don't change it, it's fine, later we can do that. And this one is 0 minus 9, there'll be 9 negative 9, square will be equal to 81, and you don't, oh shit, I forgot, so you shouldn't have the square root again because we have canceled that. Okay, so yeah, I'm gonna explain again. So why I'm not putting the square root here, because both sides have square root, so I'm just gonna leave them because both of them have the same thing. Okay, so the y minus 3 squared. Okay, now you can actually expand this bracket, yeah, so the 4 doesn't change, put over here. If I expand this, there'll be y minus 6 times y minus 6. If you forget how to do the FOIL method, please see the my previous video. Okay, so use this one. You will get y squared minus 6y minus 6y plus 36. Okay, by doing this, and then equals to 81 doesn't change, and then this one, if I open the bracket, there'll be y squared minus 3y minus 3y and then plus 9. Okay, now since we want to find the value of y, so we can move everything that has a y to the left side and everything does not have y to the right, to the left side, to the right side. Yeah. Okay, now we're gonna move this 4 and 36 to the right side, and we're going to move these to the left side. Okay, let's do that. Okay, I'm gonna write down y squared doesn't change, this one, minus 6y minus 6y can be simplified as minus 12y. Okay, and then y squared going to the left, there will be minus y squared, and then minus 3 there will be plus 6, right? So this is minus 6 goes to the other side, the equal sign will becomes plus 6y, yeah, because minus 3y plus minus 3y is minus 6y. Move to the left side, you will get a positive number. I mean, like, it will be a addition. Okay, now we've done that. Oh no, not yet. Oh yeah, yes, we do. Oh, and then the 81 doesn't change, right? This 81 doesn't change, and then this 9 also doesn't change, plus 9. and then we're moving this 4, right? This is an addition, so that'll be negative 4, and this one is also subtraction, that'll be negative 36. Okay, now let's do the calculator then. Okay, and that will be 50 over here, right? So on the left side also we can actually simplify that, because we know that y squared minus y squared is just 0, so we just cancel them, they're gone. So we only leave with minus 12y and then plus 6y, and that will be minus 6y. Yeah, because minus 12 plus 6 is 6, so 6y. Okay, now we only need to get rid of this x by dividing both sides by 6, so y will be equal to 50 over 6, and there we go.